friends, this is Krishna and welcome back to you. And today we are going to learn blocking queue. So let's set the agenda for today, and then we will move to all step one by one. So we have to we will check what is blocking queue with the help of definitions and memory managements, or we can say memory representation. Which Java version included blocking queue? We will see with the implementation of the blocking queue. Why we need blocking queue? We will take a simple example to understanding the concept. Then we will check how we can use blocking queue with a real-time example. We will see what advantages to use blocking queue, and at the last we will also look into the internal working of blocking queue. Fine. So let's begin with the first point. What is blocking queue? Blocking queue is actually an interface in Java, so which has many classes. There are many classes which implemented this blocking queue interface. And if we talk about blocking queue, so what is the definition and what is the meaning of that? So say we have two thread, we have a queue with a fixed in the size. So if my queue is empty and I'm trying to fetch record from that queue, so that thread which is trying to fetch record from the queue, that will not able to fetch or retrieve the element from the queue because this is already empty. So that thread should be in wait state till another thread, say it is thread 2, will insert some data in my queue. And another part, if that thread 2 which is inserting data into my queue, so once my queue is full, all space are full, at that position my thread 2 which is inserting or putting data in my queue will be in wait condition for the time till another first thread will take data from my queue. So let's see this with the help of some pictures. So I have some pictures here, so let me open this one. For this first, say this is green icon, this is thread 1 trying to putting data in my queue, and this is my queue with this which is fixed in size, and here is thread 2 which is retrieving or taking data from the queue. Let once a thread trying to put data, so this will store in this area, right? And once a thread 2 will fetch, or there is a method called take, that will take the element from this queue and also delete or remove the element from the queue. So say if my queue is empty in my thread, and another say thread 2 is trying to taking the element from my thread, as this is already empty, so this thread 2 will be in blocked or wait state till my thread 1 will put any data in my queue. So once there is a data in my queue, then only another thread can take data from my queue. And we will also, let's check this one. Once my all space of the queue is full, my first thread which is trying to put data in my queue, that will be in blocked, or we can say in wait state till my another thread will retrieve or take any of the element from the queue. So there is free space, then only first thread can put data into the queue. So this is the simple memory representation of the blocking queue. So in this stage it will find, like, here is some data, so thread 1 can put data, and here is also some data, so thread 2 can take some data. Okay, so let's understand this with the help of an example. But before that, let's check the second point. Which Java version included blocking queue? Implementation of the blocking queue. So here Java 5 came with blocking queue implementation in the Java util concurrent package. Another important point here, Java blocking queue does not accept null value and throws null pointer exception if we try to store null value in the queue. We will see this code or concept in the part of internal working of DQ in the later of this video. Okay, so let's jump to the third point. Why we need blocking queue? With a simple example, I have written some code here, so we will see this and try to understand what is problem if we are not using blocking queue, and what is problem with the size. So I have let me explain what I did. I have created object of array list, and which is size in 3. So here I'm storing the 3 element, and I'm printing just message list size after 3 insertion. So whatever size I will get, I will print. Now even I have said this list is size of this list is 3, then even I'm putting the fourth element in this list and then printing the size of this list. The same thing I'm doing with the blocking queue. So here I'm creating the reference of blocking queue interface. As I already told, blocking queue is an interface which has some implement classes in Java. So that we will see later what classes implemented this interface. So the same thing, I have taken 3 size of this blocking queue, array blocking queue, and putting the 3 elements in my queue. Now I'm just printing the size of my queue and putting the fourth element and printing the size of my queue. Let's run this code and see the differences. Let's come here. As you notice, in case of list, I'm able to see list size after 3 insertion is 3, and list size after 4th insertion is 4, because list is growable in size. So this will increase the size of the list if we have like all spaces are full for the list. So there is some load factor and initial capacity that will calculate the growable size of the list. But in case of queue, there is no concept of increase the size. So if we have taken a list with size 3, so queue size after 3 insertions. So till here my code compiled and executed, but I'm trying to putting fourth element in my queue, so we will not able to do this because my queue is already full, and now this is in wait state. So if we take any element of this queue, then only the fourth element will store my queue. So say if I'll do like this, if I take an element from this queue and I'll run the code once again, now we are able to see the queue size after fourth insertion. This is even size in 3 because we have removed one element, right? But as we understand what is the problem with the queue, if we are putting next element. So this is not actually problem, this is a feature of the queue. We will see in the real-time example. And before that, let me show you the implementation of the blocking queue. So say this is my interface blocking queue. This extends the queue interface, and what are implementation of this queue, blocking queue. So let me say put method here, and if we open the implementation of this blocking queue, there are some classes which has been implemented this blocking queue. So there are some classes array blocking queue which we have used, and the delayed work queue and all that, and there is some blocking dequeue interface as well which extend this blocking queue. Fine. So these are the certain classes. In our example, we have used this array blocking queue, so we will see the implementation and working for this array blocking queue. Fine. Now switch to the next point. Simple example. How can we use blocking queue with the help of real-time example? Say I have to write a code to produce some item and consume some item, and there is some service which is using for production and consumption of my item. So there's some producer and some consumer, and uh, and and we have a service which provide. So say this is producer. I have written actually code, so like we can make a short video. Let me explain the code here, then we will see the result. So what I did, I have just create a class called item process item producer, and this is actually a class which is produce some item. So I have implemented runnable interface and just implemented run method. Here what I'm doing, I'm just producing 10 items with the help of this producer class. Okay, so for I am producing 10 items, saying message like 1 to 10. This will say my item first, my item second, like that. So in my queue I am putting message, or we can say item here, right? So here I just put the item in my queue, and here I am once the item is inserted in my queue, then I'll say products produce item, whatever item, like it could be first to 1 to 10. I just catch the exception, and after producing 10 items I'm just saying this my message say item finished, and in my consumer class I'm consuming that items, right? So at which I have to consume the items till I'll get this finished, like once I get this finished, like my item is finished, all 10 item has been produced, then I'll say okay, so till this condition I have to consume. And here what I am doing, just consuming the item one by one. Okay, so here like say message dot from queue I'm taking the item one by one, so I have to consume all the item. But here is a point, like in my item service I have created a object of array blocking queue, like which is um, 3 in the size. So at a time I can produce only 3 items. So say here if there my here my loop, if I'm producing 10 items, so after if my queue is full I have produced 3 items, so I have only 3 memory area, so I can produce item and I can put the items here. So once consumer comes and consume at least one item, then only I can produce the fourth item. So this I'll show with the help of this example. So I have created the example object of item producer and item consumer. What I did, I just started production. I'm not consuming anything. So let's see what happened, then we will discuss. Here let me put this here, item producer and item consumer started, so this is printed, my production is started, but I have produced only 3 items. Why? Because my size of my queue is 3 only. So now my thread 1 or say production is in waiting state, and I have to, if another thread or we can say consumer thread will come and consume any one item, then only we can able to produce another item. So let's do with the help of say start my consumer thread. Okay, now let's see the result, what is happening. Okay, this is very quick. Consume no, this is not actually correct item, let me clear this. Fine, produce item 1, produce 2, produce 3, now consume 1, consume 2, consume 3. So in this way, like we are producing the item and consuming the item, but at a time in my space, if I have produced 3 item and there is like no consumer comes in take that item, so we have to stop our production, or our producer thread is in waiting state, right? So what we can do here, we can sleeve the thread. So say my production till 1000 millisecond, so like production for one item take 1000 millisecond, and consuming for one item take 3 second or 3000 milliseconds. So what will happen now? Let's run this code. Produce item 1, produce 2, produce 3, produce item 4. This is actually very quick. Before produce fourth item, that has been consumed item 4, but as we have put the time is like taking much to consume an item, that's why we are getting this type of result, right? So I hope you understand the point. Even let's comment this out, and let's comment this also. So like as soon as possible we are producing our items and we are consuming our item. So if what happen if another threads comes, like say producer 1, and that will start our production, so 2 production threads and 1 consuming thread, that will do same thing, like at a time even 2 production is there, even 3 production thread is there, but at a time in memory 3 items should be there. So if I have two production thread and that will produce one item one thread and two item by second producer, so the next production will be in wait state till my consumer come and consume any one of the item. All right, so this is, I think, very clear about the real-time example of blocking queue. What next? What advantages of blocking queue? Advantages nothing like what happen if I don't want to use blocking queue and we want to write this code with the help of some normal collection, say list, set, I mean array list or anything else. So for that we have to put the wait and notify method. So we have to wait for the first thread to and notify the first thread once consume any one of the item, right? So this will the same thing that is implemented in blocking queue. So let's see the example. Blocking queue, this is my simple blocking queue class. Here what is happening if I'm calling put method of this blocking queue? Okay, so if I'm putting some element from the in the blocking queue. So here are some implementation. Let's open this array blocking queue, right? So first this will check for check not null, and let's open this. If value is null, this will throw null pointer exception, as I already told to you. So value should any element should not be null. Another thing, blocking queue is put method. So this is my blocking queue, right? Here should be put method. Yeah. Put e check for null, and this is locking actually the same as the notify and wait method. So this is locking this thread, saying if count is length of the item, so the count of the memory and length of the item which are in queue, if this match, so this is putting this thread in waiting state, and once this waiting state completed, so notify, and then only we are in queuing the element in our queue. The same thing is happening with the take method, right? So if I'm taking any element from my queue, so what happening, this is just checking for the count. If my count is 0, or I mean to say my queue is empty, so this is putting this taking thread is in wait state. So once wait state is completed, now this is dequeuing the item. So once wait state is completed, it's mean another thread came and that inserted the data into the queue, and then only we can dequeue or we can take the data from that queue. And finally we are unlocking, like lock and unlock concept as same as the wait and notify method. I have if you are aware with this wait and notify concept, so that's fine, that you understood very well. But if you are not, so just go to my channel. There is another video to understand this concept, wait and notify all method. Fine. So I think this is clear, all the things we have covered. So if you like this video, please like. If you want to share some feedback and any advice, you can comment as well. You can please subscribe my channel so you can watch next upcoming video. Fine. You can also please press the bell icon so you can get the send notification for the next video. Yeah, thanks for watching and keep learning.